there'll be like an additional ruling on it to go from there. But just going off of and then so distance. So when we derive distance, you have to be within 1,600 meters, which is a mile. So if you're within, so you have to be a mile or better than the other prediction for it to display like globe or one of the globes as a winner here. So we'll go over a couple of things here. I see Roohif anxiously awaiting to get into it by sharing his thing in the middle of me sharing mine, which is very rude, Roohif. But I know you're just very excited. But we'll get to you in a second.
I'm not forcing people to watch my stream, Alan.
I know, but that's hella rude. So anyway,
your mum was rude last night.
If you don't act like that, man. So anyway, we'll add a couple other peaks here. Actually, you know what? 1 second. We'll do, let's see. We'll do the Blend Mountain ones because those are the most disputed weapons. And we'll do Getaway Mountain and Houndstooth here. So Blend Mountain. We go over one of Jesse's here. We have the true position of the star at the mountain peak being clocked at 1 degree, 21 arc minutes. The flat Earth prediction is 1 degree, 34 arc minutes. The refracted position of the star at time of occlusion is 1 degree, 30 arc minutes. So 4 arc minute difference in the raw flat Earth prediction for it. And when we derive the distances and the elevations off the occlusion, raw flat Earth is off by 81 meters in elevation, and we're off by 3,400 in distance. And then they're off by 26 meters in distance, and they're 1,000 meters in 26 in elevation, 1,000 in elevation. And what that looks like over here before we get to the refraction comparison is given the parameters mentioned earlier for distance and elevation, we get an indistinguishable comparison going refracted for true position with respect to peak. And then for external consistency test, we were closer on the elevation, but they were closer on the distance. So we have a mix match here, and a mix match is a limit of use parameter. So that is the limit of use of our tool when these two are indistinguishable from one another. When they're within about 4 arc minutes, it looks like they're pretty much identical there. And when we get into the refraction compensation here, there was a lift. There was supposed to be a 38 meter drop over this 22,000 meter distance. And when we look at the refraction correction, they actually doubled it. They predicted what is it? They tripled it. They predicted 130 meters in lift, 131 meters in lift. So in this comparison, like, does this prove a globe? Like, no, but it doesn't falsify the null hypothesis. It doesn't show that the method doesn't work because the clearance difference between the peak and the occlusion was three arc minutes. So the numbers that gave an elevation that correspond to the peak's actual elevation, there was a difference in the true and refracted position of 3 arc minutes. Right, the globe would predict that it should still be refracted because remember this was an occlusion. So if it's refracted up and the true position intersection has no relationship to it, then the star should have been visible well before that. But there's a 4 arc minute difference between the true position and refracted position. So the methodology is entirely sound and proven, and we could use this difference that correctly derives the elevation to kind of calibrate a difference from what reasonable refraction looks like to what it looks like when it's just overcorrecting by thousands of percent or by hundreds of percent to make it appear like it's flat. So that was Blend, and we'll go over Getaway Mountain. I think that was another one. So same scenario here. We have the true position at 45 with respect to the peak, and the refracted position with respect to the observer to the peak is 45. So damn near. So these give damn near indistinguishables as well. Very close predictions. And then when you get into the raw, they're only off by 84, but their distance is off by 4,000 on the raw. But because of even though the distance is long, like it's 48,000 meters, but because the refracted position and true position are so close, the compensation is it makes it indistinguishable. So they predict 800 or 188 meters of drop, but they have 370 meters of lift. So they're overcompensating by 182 meters. That's basically, what was that, like it's almost double their prediction. Or I mean, it's almost the same amount as they're predicting for drop is how much they're overcompensating for. So I think this creates a pretty interesting picture here, especially when we compare it to the raw positions, which is it gets more revealing there. But if there's any, see here, is there any other ones I wanted to go over? Oh, North Peak. Old North Peak. So this was our largest distance yet. This was 130,000 meters with an occlusion angle of 1 degree. Oh, I'm sorry, 58 arc minutes. So just under a degree at the true position with respect to the peak. And then the apparent position with respect to the peak is 18 arc minutes. And their true position is 1 degree and 48 arc minutes. So they actually predict that this is beneath this is the negative coordinates that we've all been having a discussion about. So this is actually below the 11 arc minutes, I believe, on the conversion when you do how much they lifted it up. So when you go through that, we get the raw trig for what the flat Earth predicts, 45 arc minutes for our raw angle. And remember, their occlusion angle with respect to the peak, or the refracted position, was 30, that they lifted up by 30 arc minutes. So we're at 35, or we're at 45, they're at 30 with their refracted. But then so we get an elevation difference of 500 meters with the true position of occlusion timing with respect to the peak. We get a distance difference of 30,000 meters. And then for the refracted globe, they're off in elevation by 1,000, 1,100, and in distance they're off by 270,000. The refracted globe position at the time of occlusion with respect to the observer, like just whatever the observer sees, that angle gives them 1,000 meters off and 192,000 meters off in distance. And then following the raw trig, they're off by 1,300 meters. I'm sorry, the raw geometric position of the globe, the one that does the occluding. They're off by 1,300 meters in elevation, and they're off by 500,000 in distance. And then doing the spherical trig comparison with the refracted position, they're off by 330 meters in elevation and 13,000 in difference from my secondary analysis. And then what we have here, though, is a negative expected drop amount here, meaning the refracted amount failed to compensate for when the star was actually occluded. So that's a huge geometric failure for them because it's supposed to be, under the horizon at that point. And even with their drop over distance, or even with their celestial refraction to compensate as a refracted lift mechanic, remember they predict 1340 in drop, and they only have 1140 in lift. So they're off by 199 there. Huge failure for them, and it gets occluded at a time that closely corresponds to the flat Earth angle. So this distance is extreme. Like, we're all off a little bit, but it corresponds to our angle and not anything below the horizon or any crazy stuff like that. And so the difference that they get on their what was it? This one, geometric clearance, expected drop. Yeah. No, wait. Yeah, a difference in 40 arc seconds between true position and observer position. And we learned earlier that time of emergence, time that when we see the star, happened within 4 arc seconds of the true position and the refracted position aligning. So we know that this 40 arc second, to even like entertain that as a possible solution, is just ludicrous at this point. So that's where we're at so far with the analysis, and I'll do some things to clean this up and make it more clear, and then there'll be a summary column over here with parameters and everything laid out, and then we can have the data comparisons in a nice tab, or nice tabs over here where all the positions are represented. But if anyone would like to play with this tab or play with this spreadsheet, the link is here. You're free to make a copy yourself, or I guess that'd be the only way you could play with it, huh? So yeah, you're free to make a copy yourself, and how to use it is just change to a peak. All the relevant stars will then be displayed per the peak. And then if you ever want to add something, go to the old data table here, add in the same corresponding order that we did, and everything should automatically update in your drop-down menu relevant to that peak. All right, any questions, comments, or concerns?
I will let someone else go first because I'm polite.
Thank you, Roo. A true gentleman.
There's a couple people in chat that had questions. I think Chief Squatting Dog.
I'm gonna dig through this, and I'm gonna make sure all the everything is like referencing everything correctly. And I'm just gonna look over the basic formula because it kind of looks a little fooey.
Nice. Please do let me know if I have anything off.
Yeah, the results can be disgruntling. A lot of people feel the same way, but now that every method is now included, if you find one that isn't, definitely let us know and we'll add that method.
Yeah. Well, I'll look at this equation here.
Nice.
And then we'll hope that the guy like actually measured correctly to begin with.
Well, the methodology is so easy, even I could do it. So I'm sure he nailed it, because he's much smarter than I am.
Doubtful. I mean, not doubtful, but like not saying
your
much.
aspersions are noted.
Yeah, that's fine. I'll look.
Anywho, Ruski,
also,
what do you got
why are you
for us,
using the
big
term
dog?
occlusion when like it refers specifically to orthodontal work? Do you mean to use a different vocab?
I mean to use the time in which something gets occluded by an object.
Occlusioning,
brother.
A dental term.
Occlusion, the process of
occlusion is not just a dental term. It's a process whereby something is hidden or obscured from prominence or view. The fact that you Googled it and just looked at one definition is absurd.
No, dude, the celestial theodolite is the celestial theodolite is actually a dentistry method. So
it's
actually just busted
procedure.
us. Yeah.
Do you mean to know your vocab better before correcting other people's vocab?
I'm just looking at the top 7 ones, and that seems to be what it is.
I cannot believe you didn't look at the second definition that Google lists. I cannot believe that.
Guys,
polar relationship.
All right. We're having a secondary conversation on some semantics.
Especially when you correct people on it.
Hey, I have a quick comment, if that's okay.
Absolutely, Lily. What's up?
Yeah, last time I was saying that Dr. Heffron's method and his experiment are so brilliant in their absolute simplicity in terms of, anyone can do this experiment and see for themselves. But also I wanted to point out that it's such original thinking. Dr. Heffron, I hope that this catches on in our community, and a lot of us do a lot of original thinking, because I cannot praise the originalness of this thinking enough. I know that you give the credit to God, which is fine. I don't mind doing that also, but you were the channel. And so, but I hope that it inspires our community to come up with such original ideas and thoughts that are brilliant in their simplicity and their originality. So I just wanted to point that out. Thank you. And also, I think, after 3, 4, 5 months of discussing this particular subject, this particular issue, I feel like if people aren't getting it, then it's either like, I don't know, it's a dishonest, intellectually dishonest, or it's just mental incapacity mentally to really get something that maybe a little bit beyond their level of, what they can comprehend. So anyways, thank you for all of you for spearheading it.
Chief's going, no, we're not doing any more of that. So we're not taking any more questions from someone who cherry picks a definition. The second definition says a process whereby something is hidden or obscured from prominence or view. We're not going to have you just troll and waste all of our time.
Thank you, Gally. Roohif, I think you are the next one up.
Cool. So Shane basically refused to do this last week. So Alan, can you steelman the globe position using, say, Pikes Peak as the example?
Which globe position? There's like 7?
Yeah.
You got to be specific.
Which one? The terrestrial refraction one?
219.
Yeah, to include terrestrial refraction and use 219, of course.
Yes. Okay. So
yes.
Okay, so that's 219. And according to the globe again, what angle did the star occlude at, according to the globe?
234.
222.
That's not a steelman. That's not a steelman either. You're close, Alan. You're close.
Hold on. No, I have the stellarium position. It occluded at 222 with respect to the observer's position. It occluded at 2. It occluded. Hold on 1 second. I didn't adjust anything. That's just the angle from the position. There's nothing to adjust.
Yes, there is. Did you adjust for the pressure, his elevation?
What?
Did you adjust for his elevation above sea level?
Bro, Roohif, I just use the angle that the star was at with its celestial refraction applied. That's all we're doing trig based off of. We don't care about the actual elevation of the mountain. So
you're aware that stellarium thinks you're at sea level, right?
Are you aware that? Oh, so you're saying that there's a different refraction or a correction that'll be applied there?
Yes.
So it won't be 222. Okay, what is it?
Correct. 219 or 218 and a half.
218 and a half. Yes. Okay, well that still doesn't help because I have 219 raw calculated out for distances and elevations too. I did them all. I did the refracted position and I did the
wait.
I did the terrestrial refracted globe and I did raw globe. I did them all.
Right. So the mountain is 219 and the occlusion happened at 218 and a half according to the globe. That's a match, correct? Half an arc minute.
No, not according to the globe. According to your nonsense superposition, we're using a refracted in a different position entirely. It's entirely a different metric, right?
Yeah,
sure.
Yeah. Rue, hold on. 1 second. No. We've steelmanned it, but listen, Rue, if the refracted position is they added 16 arc minutes of refraction, that's equal to the flat Earth angle. So like the different, like with the comparison that you're trying to say is that like the refracted globe position is equal to the flat Earth angle, which if that's your position, touche, I guess. But we're considering the raw as well.
Half an arc minute error. The question was whether you can steelman the position of the globe. No, I don't care about the Theo. Can you steelman my position?
You mean your retarded version of it? Sure, we can.
Listen, Roohif, I don't understand what you mean when you say, can you steelman it? Because I included all of the angles that you could possibly need and did the calculations based off of whatever those angles happen to be, given terrestrial refraction, given celestial refraction, although I will adjust the elevation for that one. But even using the elevation that you're suggesting of 219, I have it. I have it right here.
Do you?
You're off. You're
numbers look anything right.
You're off for using the okay. Pikes Peak.
There you go.
39 Aquarii.
There we go.
Okay.
Cool.
For using 219, we get an elevation of 30 minutes or 30 meters in difference to 800 meters in distance. You guys get 172 meters in elevation, and you're off by 4,000 in distance.
Okay. So question. All right.
Yes.
So my inputs to get 219 are like the distance, delta height, and terrestrial refraction, and globe drop, obviously, right? They're my inputs. Right? And then I get 219, and my star occlusion angle is very, very, very close to that, right? 218 and a half. Right? So does it make sense to you that when I plug in that very, very, very close angle back into that formula to derive a height or a distance, that the number is off? Does that make any sense to you?
Our premise, again, like whether or not it makes sense to you, this is what we're testing here. So when we do that same thing with the true position to the peak, we're somehow able to get our distance, usually within a mile or two, and the elevation of the peak. And you guys are consistently off when you do that.
Okay, so I'll say it again. Let's assume that my star occlusion angle is exactly 219. Right, so it's a perfect prediction. If I then go and plug that back in, right? If I go and plug that back into this distance check or height check, does it make sense to you that either the height or the distance would be wrong?
Well, the angle should correspond, or the timing should correspond to what the globe predicts. So the distance that you derive based off of your angle should closely predict where you're at. And it doesn't. The flat Earth angle does.
I'll say it for a third time, right? If I plug in the distance, the height, the terrestrial refraction, and the drop, right? If I plug in these numbers into a formula to get an angle,
like I did.
Right?
Yep, I got 219 when I did it. Yep.
Then I just assume for the sake of it that my angle that I observe just happened to be perfectly correct. Right?
Yep, that's what we're doing here.
If I then go and reverse engineer a height, if I go then back to that formula to reverse engineer a height or a distance, does it make sense to you that if I plug in that exact perfect angle, that my output would be wrong, like the distance would be off by anything? Does that make sense?
Well, it's going to be a ratio of the known constant, which is the elevation that we're using, and the angle that you get. And we have mutually exclusive angles. So the distance that you get out of that is going to be dependent on your mutually exclusive angle.
Do you understand why this testing this?
Do you understand why we're doing this? Because for all your griping right now about the refracted position and how it doesn't match, what you don't know is when you take that angle, it doesn't even do it. It wouldn't even do it at 218. It would then be off. So I'll have to adjust it because it's off there too. So yeah.
I don't know any other ways to say it, honestly. When you say the distance is off by 4,000, right?
Yeah.
How is that possible if my prediction is only off by half an arc minute? Or my height is off by 172 meters.
Because you're deriving your distance based off of the refracted angle, and we're deriving our distance off of the true position angle of occlusion.
It doesn't matter what you are doing.
There should, well, it does, because there should be no geometric relationship between what we're doing and what you're doing. There's no reason why we should be correct and you should be off.
The chief squatting dog just said in the chat, it's because you're doing the formulas wrong. That's what I'm trying to get at. Right, you're not like Stone said yesterday in the stream yesterday, where Stone said you've just you back engineer numbers. I'm fine with that wording. That's completely fine with me. But it's just reversing the formula. You're clearly not reversing the formula correctly.
So no, we are, because when I first started this, I was actually listen to me, please. When I first started this, the distance derived was exactly back, but that's it would always equal back the angle for flat Earth, because I was using, like, it was circular the way that you're asserting. But if you use just the elevation as the constant, the control, or the difference in elevation, and you use the occlusion angle, which is a dependent variable that comes out of both of our predictions, because you predict a different angle, we predict a different angle. So we're going to get different distances out of that. So now we're seeing the differences in distances in the comparisons, because the globe is built on apparent angles. So I have no problem doing a comparison for what it happens to come out with at 219. You saying it doesn't make sense and we expect a different angle, that's the premise of this. To see which one matches reality. Go ahead.
I'll try and explain it generically, right? You know the equation of a line, right? Y equals mx plus b, right? I stick in an x coordinate and I get a y coordinate. If I stick that y coordinate back into that formula, I will get the same x that I put in. Right? The formulas are rearrangeable and reversible.
No,
right?
That's not
Yes.
because if we put it if we put in an angle that doesn't correspond to the occlusion angle, we would get a different distance. That's what I'm saying. When I change the ratio to get it so that it's not circular, we can get actual differences in predictions where it's not circular, where it doesn't give you the loop back.
What Roohif is disagreeing with is the actual application of using his refracted angle in practicality to measure things. He wants to subtract and remove the so-called geometric curve and refraction correction that he applied to get it in the first place, right? We already went over this in depth.
So he actually wants to change the observer location. Is that what you're saying, Shane?
I think he wants to, so once he gets his refracted angle, his lower geometric and refracted angle, as soon as you want to measure stuff with it, he wants to straighten that back out and remove that refraction so that he can get a correct elevation and distance.
Yeah, dude, I don't care about any of that, bro. We're doing raw for raw and deriving distances. If you have to do all this like weird stuff, that's a completely separate thing. But I'll pull your thing up and you can go over your spreadsheet. Yeah, no, so we're doing a different. Okay. You're strawmanning us, bro.
No, I've done your procedure.
You didn't like the answers you got, so now you're trying to do a different one. That's a post-diction, bro. We're externally testing the internal consistency of your guys' model. When we test it internally consistent, it's pretty much still goes the way of flat Earth, and in a couple of cases it's ambiguous. When we go raw for raw, you guys are off every time. Like this whole disagreement about you're basically, like Shane said, you're basically just disagreeing with the application of it. And if you disagree with that, your contention's noted, but like largely irrelevant. Because if I can find my distance using this method, then everything you're saying about how you disagree is irrelevant. I can find my distance just off of an occlusion angle and a peak.
So can I.
And even arguing over this refracted position nonsense is not even the true Heffron method. You're using a true occlusion time. You're off in fairy tale and using a refracted occlusion time from a different place. That's not the actual original method. It's entertaining your method. We should call it the Roohif method, and that's what we're entertaining now with full-on analysis, where it still fails, right? Which is why we're arguing it.
Yep, and even doing that, it's off by 172, and it's off by 4,000. So.
Yeah, because your formula's wrong. Like I said, if I predict 219,
my formula is the same thing that I did for the flat Earth prediction, bro.
Hold on. If I use the distance to predict the angle, and my angle is an incredibly close match to the actual angle, how is it even possible to then reverse engineer that formula to get a distance that's way off? Obviously, your formula's wrong. Obviously.
Let's go over it right now.
You can't have your refracted triangle and eat it too, right?
My formula is not on. It's just the same thing that we did with the true position. So for the flat Earth, we're referencing true position at peak. For globe, we're referencing refracted position at the peak.
All right. Do we want to waste everyone's time and reverse engineer my 219 back into a distance? Is that what we want to do? I mean, I can do that.
I did the same thing.
It'll take me a while.
I did the same thing doing the same process.
Because you're off by 4,000. Clearly you didn't.
Okay, well, let's see what we did here. We did E12 plus B19. E12 is standard refraction.
Okay. No one's...
That's globe slant.
No one's going to watch this one.
One second. I don't care.
Tangent of the radians. That's it right there. Divided by the tangent.
Or which one?
Basic angle, globe angle, divided by the tangent. Yeah. Wait, no,
one. I mean, this is what we're all... What exactly is your argument? What exactly is your argument?
Me?
Is you laid out
the globe, which I'll show up 1 second.
Oh, right here.
Yeah.
That was the stream.
Yeah. Distance times the occlusion angle, bro. Or whatever the refracted angle is.
Yeah, where's
in your case, you want in your case, you want a 219, so it goes off of the 219 angle.
Yeah. Right, but where do you account for drop and refraction, which are inputs into the formula?
In 219 already. You've already used it.
We already did. We already did. To get to 219, we had to subtract the drop over distance, which was 213 from the
flat Earth prediction.
I was just here last week, and Roohif said 219.
You got your voice changer on again. for some reason.
That's
I was like,
but yeah, there you go, Toby. You're live.
I'm just gonna say I was here last week, and 219 came from Roohif.
Yes.
I'm 219 out of my mind. Yeah, that's why it's in here.
The inputs into that formula.
Yeah,
but you know how to rearrange formulas, right?
Yeah, and we're not doing that because it's not circular. The flat Earth one gives a different distance for its prediction, and so does the globe, because it's based off of the occlusion angle, Roohif, not the actual Dude, the actual input for the angle, right, is the prediction. So it's like based off of the ratio of the elevation and the distance. Stop! Don't interrupt me. It's based off of that. It's based off of that ratio, right? It just happens to line up with the refracted peak angle, right? So when we do the same thing that we're doing with the true position, we get a distance that's close to ours, and yours is off, and you're saying I'm doing it wrong, and you're saying that why would we expect a different distance? Because we have a different input for we're using the angle and deriving it off one of the other known variables to derive the other for comparison. So for one, we use the known elevation difference and the occlusion angle. That gives us whatever distance that would have had to have been to create that angle. Now, when we do the same thing with the angle and the distance to get what the elevation would be, that's why we get things that are different so we can compare based on the actual occlusion angle, which is our predictions. And where was the star's true position when it got occluded? And I figured you guys would want the apparent position when it's occluded. So when we do 219 or 218 or whatever numbers you guys want, that's why they're off. That's why it doesn't reflect that. That's what we're saying when we do this with our method. It's reflecting the geometry of reality because there's no drop over distance to create the angle of triangle that you would need to derive your distance more closely and elevation.
Right now, you're arguing to just subtract that globe to bring it back to flat.
Yeah, your argument
is the Steelman occlusion angle. What is the Steelman occlusion angle?
It would be 217 raw, 218 or 219 if you added refraction terrestrial, but we don't.
Right. So that's the Steelman occlusion angle. If I plug
that's
that
the
back into
Roohif
the formula, you can straw man it all you like, Shane, right? But if I plug that angle back into the formula, I will get the same distance. Because that's how I got my 219, was using 50.7 kilometers. So I plug it back in, I get 50.7 kilometers back. So
what elevation do you get? What elevation do you get off of that, though?
Exactly.
Because you can't whatever the elevation would have had to have been to create the mountain peak. Because that can't be the same then.
219.
It would be a different elevation, 100%.
Yeah, then
if you have the same distance and a different angle, you're gonna have a different elevation, bro. If it's 231, it's a higher elevation. If it's 219, it's a lower elevation. So it's different.
That's why we compare them separately.
219 on a globe.
That's why we compare them separately off of the known variables so that we get the approximation with just the dependent variable, which is the occlusion angle, and the control, which would be the distance or the elevation, respectively.
Right.
So we're not doing it wrong.
219 is the prediction. Yes, you are, because you're getting an error of 4,000 meters for the globe.
You know that every step of the way so far, with every formula, it hasn't been the globe is wrong. It's that, we made an error in representing the globe. That's how we ended up with 7 different methods to predict globe draw. Notice whenever one of them doesn't quite do it, it wasn't, the globe is wrong here. It's, here's a new formula that we need to apply with a specific ratio of new terrestrial refraction that now brings it back. So that's why we have 7 different methods right now, Roohif. So you want to, none of these in singularity by itself is more consistent, right? We're allowing you to pick any of these at any given point that are higher. Okay.
Let's just humbly call me the king. I'm the authority on the globe method. All right. Attack my globe method.
Oh, I don't have to. The null hypothesis is my own. I've failed to falsify it. I have no single measurement that from my analysis that shows that there's a mutually exclusive globe proof. I have indistinguishable measurements and measurements where the globe's way off. So, so when you say attack
on my screen
my globe method, I have no need to do that. I've already done it.
Now is a comparison between the actual globe method, the blue line, and its deviation from prediction, and then the red line is the celestial theodolites prediction versus the flat Earth angle. It's all over the place.
Where's the actual physical occlusion time? I don't see that listed or compared anywhere.
Times.
What's going on with that?
Times are in here. These are all the times.
From the mountain, right?
UTC. Yep.
For both predictions, right? You're comparing the globe from the mountain and flat Earth from the mountain, right?
Yep. So that's, no, not from the globe doesn't.
No, of course not. You're doing totally different. You're doing a completely different metric, dude. You're applying the globe from a different position to the observer, and you're applying. It's so retarded.
Yeah, I'm doing the non-strawman version, Shane.
No, you're doing.
Let's just agree on what to call it, dude.
Listen, we don't have to get insulting, but what you're doing, Rue, is an internal consistency check. We're doing an internal consistency check with our method and an external one, and we're giving results that show that the Earth is not a globe. So when you're doing an internal consistency and you're like, look, when I derive it based off of these variables, it comes back to the same distance, that's expected. Like, you're doing a different thing and then saying that we're strawmanning the globe. But I told you we're testing it externally and internally using the occlusion method. If you don't agree with that, that's fine. If you say that's a strawman of the globe, that's fine. But you're referencing an internal consistency check to refute our data and then say attack my globe position. Bro, the whole purpose of what we did has refuted your internal consistency check. But go ahead.
Hold on. So this column here, so this set of values here in particular, are the deviations from prediction for Pikes Peak. You'll see they're all less than an arc minute. That's amazing, quite honestly. The celestial theodolite, doing it your way, testing your method, it's always about 2.5, 3 arc minutes off. All right. You go down further, when you got Cheyenne and Blodgett Peak here, they're off by 4 and 5 arc minutes. What's this one? North Peak, Greenhorn, off by 14 arc minutes. Jesse's Blinn Mountain off by like 15 arc minutes. Your method.
But you're literally doing apples and oranges.
Results.
Right? You're doing flat Earth from the peak to the star, and you're doing globe Earth from a different position using a refraction to.
Yeah, you're using a different position.
It's a completely different method. You have a different metric. You have a different occlusion time. You're pretending that true time isn't the actual time. And for the globe,
you have a solarium angle of 219, bro. You have 219.
You have different occlusion times. What are you even comparing? This is retarded.
That red line is your method.
You're not comparing to anything. You're comparing it to a completely different method, which is looking at a mountain to gauge its elevation, a known process since 300 years ago, which is unrelated.
He seems to not
completely red line compares. The red line compares.
As an outsider, can I ask a question for some clarity? Can I get some clarity, Roohif?
Yeah.
Hey, Roohif, how are you still using the measurements of the occlusion timings?
Yes.
Okay, can you show me?
Occlusions here. Boom. Goes in here. Oh, which freaking formulas do I got to unhide?
What are the positions?
No, but how is it in your chart?
Yeah, hold on. I got to figure out where those times are.
Because Shane says you're using apples and oranges. It sounds like you're basically looking at the wrong metric.
He's comparing two completely different metrics. He's comparing true occlusion with flat to refracted occlusion observed from Heffron's house to the mountain. Completely around.
Yeah, he's using a different position of where the observer is. Our method is using the peak to the star.
How is the occlusion even going to be relevant if you're not even in the same position?
Here we go. So these columns here,
he's not going to answer
work
that.
Out the hang on.
Roohif, you were asked a question.
These columns here.
He seems to be ignoring.
I'm trying to answer the first question. The question was, am I using the occlusion time? The answer is yes.
Okay, and we got past that. You're showing me here, but then now I'm being told that you're not even using the same position. If you're not at the same position, how are you using the occlusion timing from the position where it was actually physically observed?
All right, so there are two things happening, right? Two things happening in this graph. This one is showing the deviation from prediction. Why are you laughing?
Because he just asked you a question and you glanced past it like 3 times, bro.
Well, let him try. Let's give him some time. Let's see if he can cook something.
Right. So this red line is showing the deviation from the predicted angle, right? So you move the observer to the peak, turn off the atmosphere, get the star angle, and then you compare that to the flat Earth angle, right? That's this red line.
So you're not using
all over the place.
observations?
These are observations.
Roohif, we don't dispute the optical angle difference. That's not our argument at all. We don't care about that at all, bro. We're deriving our distances and elevations based off of this. You're doing it like, bro, you're not like oh man.
You're not using the observation.
That's crazy, bro. Roohif.
He's just shitting everywhere. Yeah.
Yes, I am.
Roohif.
Yes, I am using the observation.
Yes, you are, bro. Listen, I can.
Yes.
Not in the correct way, bro. I can derive my distance and location. You can't. You're not even doing the same thing. You're doing angular comparisons. That's not what we're doing. That's not at all what we're doing.
Oh,
that hasn't been the method.
To distance.
That has.
That's why I like the different name for it. It keeps it clear and succinctly different, right?
Roohif, you know what you're doing. He knows exactly what he's doing.
Dude, I know, man. We've been on this for a hot minute. All right, Roohif, it's been a pleasure, man. I'm gonna have to go ahead and take some audience questions here, and we'll come back to you next week or something. That's insane, bro. That you just did that all for an angular comparison. To sit here with your chest up, come in here streaming over my stream, talking about fucking angular comparison when I got you didn't use the right angle, you did it wrong. Yeah, no shit, because I used your refracted angle, and that's why it gives a different distance, bro. That's
just to summarize the globe.
Just so everyone's clear here, right? Yeah, just so everyone's clear here, what just happened? Like Shane just said, every step of the way, the globe is wrong. To only obfuscate and turn it around into
the blue line, Alan.
Optical comparisons, which is not the method at all. This whole spreadsheet about deriving distances and elevations, they just did that for no reason. It means nothing, has no physical implication. I can get my location from a occlusion time and an angle. This man sat here and said, I can do the same. He didn't do the same. His graph is not even related to what we're doing. He absolutely can't do the same. This is what it looks like when the globe tries to do the same. It's off. It's not the same. That's preposterous, bro. Thanks for coming on, Roo.
Dude,
I really
wrong every step of the way.
Wow.
And then at the end,
my prediction
change it all entirely.
Dude,
if my prediction is
spot are there any questions from the audience, boys? And what's up?
I'll say this, and then you can mute me, Alan.
Wait, Alan, I would like to respond to Roohif afterwards.
I've got to respond first,
man.
right? If my prediction is 219, and then the star occlusion also happens at 219, how is it even possible that when I try to reverse engineer a distance that it's not what I input?
Okay, Roohif.
Right.
Do you remember when we first brought up the celestial theodolite method? Do you remember what you said about how the true geometric angle from the peak to the star matches a flat Earth baseline? And you were like, oh, that's just a cosmic coincidence. Remember that?
Yes.
Where are your occlusion angles from the peak to the star in your spreadsheet?
That's the red line. See how the Pike's Peak one is
so
great,
that's our method, right?
2 or 3 arc minutes off. Yeah, the red line is your method, and it's about 2 or 3 arc minutes off for Pike's Peak. Like I said, that was a bit of a coincidence. And like we said, Mount Rosa, because of its combination of distance and delta height, is going to be very close to being a good method, a good result. But the rest is rubbish. Look at Cheyenne and Blodgett and North Peak and Blinn Mountain. They're all rubbish.
Yeah, but Roohif, you do realize the method itself, right? Stellarium does not know how far away you are from the mountain peak. You know that, right?
Fine.
Okay. So if you were to derive the distance with 219 and your elevation, what angle would that be?
Yeah,
would it be 219 or would it be 231 or would it be a different angle and different height, different distance?
No, yeah, you misspoke there.
Reverse
It would be distance. There's no globe number, bro. There's a fucking elevation angle for a mountain peak. That's our constant between the two. And there's 2 angles of comparison. When you do the angle versus the elevation for 219, you get a distance that's off by 5/4. Hang on one second. Let me change it back to Pikes Peak.
Yeah,
you get a distance that's off by 4. Shh, dude. Okay, dude. It literally can't give the same.
It's two different angles.
I'll say it for the last time. If I use a distance to get an angle and then I put that angle back in, I will get the same distance spat out. Like it's basic.
That's why we're not doing that, because that's circular.
Right.
We reference both of them from a different perspective. So for the one we reference the difference in mountain elevation to the occlusion angle, and then for the other one we reference the distance to the occlusion angle to get the elevation, and we compare both differences. We don't do them the same, because then you would derive it exactly back to the same. That's like dude, when you say no, it's not a straw man, bro. It's literally two different fucking things based off of the one that should have no geometric relationship, and the other one should give you the exact distance based on the globe angle. That's not a fucking straw man. That's externally and internally testing your guys' method. The position is to use the refracted position. The globe position is to use the refracted position to derive the elevation and distances, the same way that we did the flat Earth for the comparison. Anything other than that would be to straw man the globe. There's no other position I could use.
The Steelman is a 219 prediction and a 218.5 observation. If I reverse engineer a distance from that, I'm going to get very close to 50.7 kilometers.
All right, Roohif, tune into my stream real quick. Let's take a Gandy here and make sure there's no straw manning going on here. So you want 219, right?
Yep.
Okay. If we do distance times the tangent of the occlusion angle, we get I'm sorry, that's for elevation. We get an elevation of 192 meters. Okay, the actual elevation was
right. But why are you not reverse engineering it? Why are you not back engineering it?
Because that would just give us the same thing. It would be circular, and I do the same thing for flat Earth, so we get two separate predictions per thing. What do you mean, Jesus, dude? And then so for distance, we do the distance times the tangent, or over the tangent of the occlusion angle. So we have two independent things based off of the occlusion angle and the known variable, so we can compare how each model fares to deriving it in the way that you want to. This is the best way to see which method is right, because if you do yours, which is derived off of optics, it's going to be internally consistent. It's not going to be different if you don't change one of the other variables. That's why we do it that way. If you disagree with that,
every day, all day.
No, that's not a dude. If it's a straw man, then why is the distance close, but it's not what it is? Like, it's not a straw man. They're both like, there's instances where flat Earth is off, but then globe gets close too. Like for Jesse's data and stuff, it's not a fucking straw man, bro. And when I get into the apparent refracted position with spherical geometry, it's even closer. It's within a mile. So you're gonna call that a fucking straw man if I could find my position using the refracted position or the true position with the peak? That's not a straw man, dog. If I can accurately find my location on the graticule using occlusion timing and one known variable of the mountain peak, that's not a straw man. That's dead on fucking maths accurate. You're
okay.
refuting nothing and doing a different methodology, and it's frustrating.
Right. I will say it one more time, and then I'm just going to drop, right? If my prediction uses 50.7 kilometers and gives me 219, then my observation in reality gives me very, very close to 219.
Just drop. Nobody wants to hear you anymore.
I'll start again, bro. All right. If my formula...
No, you're actually not going to start again, dude. You're going to go fuck off. That's insane.
He was
all I did was detract entirely from the point of the method. Yeah, let's not use true occlusion times and deviate everyone entirely to a refracted.
No. So listen, so pay attention, globe lads. The point here, right? If you're going to refute this based off of occlusion angles, you have to be able to find your distance. Remember the argument of, how come I can use the stars to find my location? How come blah, 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 sky, I can globe? Right? Well, we're doing the same thing with occlusion angles using plane trig and also comparing what the globe would do for their physical elevation to the mountain. They should be closer. We should be off. It's always they're off, or it becomes indistinguishable in the predictions where their refracted angle is equal to the position, the true position at the mountain peak, which makes it indistinguishable. They're never better than us in prediction.
Did you guys kick Roohif?
Sure did.
He was just debating you guys.
If that's what.
Nice.
Quote from Roohif. I'm going to repeat this thing I said for the 30th time, and then I'm going to restart in the middle of it. Like, nah, we're good. While simultaneously not acknowledging the method or doing anything and saying that we're doing it wrong when there's no possible way that it could be wrong if you do it the internally consistent way. If you do it a way that compares it, you can see the distinction between the two. So his whole point was to come here and obfuscate, not do the method, not acknowledge it, say that we're strawmanning the globe while simultaneously providing every possible way in methodology to represent the globe, to be fair to it, to represent it to our actual methodology, which provides our distance and elevation to a mountain peak. Something that they can't do. And he talks about it.
Toby asked him direct questions. He did not answer those. Instead, he went back to his chart, his graph, said red line, blue line. He did not answer anything Toby asked him. And Toby
on behalf of Roohif.
I would want to reiterate one thing I brought up last week that I think is just as relevant now is like, where were these objections months ago when you guys were planning this methodology out?
Dude, when we started quantifying it, then it became rubbish. First, it was just an interesting coincidence. Mike bought his house 11 years ago, and he's a flat Earth plant, and it just so happens to be flat where he lives, and all this ridiculousness. Right. And then we started doing it at other places. Jesse went out and did it. We started looking at the data, comparing it. The methodology solid. The occlusion timings happen within 4 arc minutes of intersecting with the peak. And then we get into we get the ability to analyze the actual differences and how much refraction impacts it. We see it's equal to double or tripling the amount of expected drop, completely compensating. The refracted angle is giving accurate distances and positions when it's close to the true position of the peak, the actual elevation. Like Mike's position is completely substantiated through all of this, and the only thing we're getting back in return is like my angular comparison. And how come when I use 2 known variables of the triangle to get it back to the distance, it would work out? Because what he didn't tell you about that, to get the 250 distance, to get the difference elevation, he has to use the actual elevation and not the drop over distance one to get it to get it to come back to it, which he can't do. So that's why he didn't show it.
So this just making it flat.
So this whole thing, like quote from the people that were like, if I was ever given evidence of a flat Earth, I would admit it and all this stuff. Nah, dog, you're just straight walking away from it. We have repeatable measurements that anybody could do. We have spreadsheet analysis on all the comparisons, all the angles you could ever possibly want. And the only thing that seems to be consistent is when it's a flat Earth angle. And even when you get into the spherical trig analysis using the graticule, which gets a little complicated, but even in using that with the flat Earth angle, it comes out to be accurate. Like it comes out to be the accurate defining measurement. And there should be no relationship. It should be dead wrong.
Audience questions? I got a couple. If you want audience questions,
I've been waiting
to move on from the obfuscation if you want.
Yeah, good call. So if there's any audience questions, if anyone has any actual questions about the methodology, the differences,
John just said he has a question.
We're happy to take them.
Yeah, I got 3. I got 3 audience questions. So the first one is, why are you using Google Sheets for trig functions? Google Sheets is so cancer. This is literally the worst format to check work. I'm an accountant. I wouldn't use Excel for trig, let alone Google Sheets. So that's the first question.
Oh,
so that's a nothing.
Well, get out your fanciest TI-86 calculator out. Do the same arctang functions that I did, and see if you get a different, more betterer result than what I got, and let me know how that goes. And show me in your fancy spreadsheet the deviation between the two. And if you use Google Sheets, it's unacceptable. Next question.
Can you guys hear me? Am I here?
Yeah, John, we'll get you in for the 10 minutes you were asking for after the 3 audience questions.
Yeah. Okay.
All right. The next question was, ask them why the southern stars don't rotate around Polaris, and how do you navigate using the stars in the south, considering the stars aren't where they are on a flat Earth? How the F do we never get in the south using the stars? It's not really relevant, but
the apparent that has nothing to do with the methodology, but the apparent positions of the stars is what was used, and they used to do rhumb line sailing, which is they would have checkpoints where they would go to a position, adjust their bearing, go to that other position, adjust their bearing again. You could look up the Perry-Reese map. That's the baseline for rhumb line sailing, and that was rhumb line sailing before they had latitude and longitude. So when you look up the what rhumb line means now in modernity, they've redefined it to mean a straight line over curved lines or whatever. But they were doing this before they even had latitude and longitude. So the idea that a rhumb line is mutually exclusive to going over a curved line is retarded. It's been redefined, but that's how they used to navigate. None of them were globe lads. Back in the 1400s, the Chinese had an expedition where they were doing the rhumb line bearing sailing using the Perry-Reese map. They sailed all around the world, discovered a whole bunch of stuff. Even Magellan going through the strait, he wasn't the first person to go through it. The Chinese were, and then he even made references to the stuff that the Chinese were talking about in regards to other locations. So there's a history of that, and they were all geocentric flat earthers, by the way. And then up to the 1800s, the Buddhist monks and Shintoists over in Japan were geocentric flat earthers, and there was a working geocentric flat earth model at the Tokyo World Fair in the late 1800s that was on display for a number of years, that basically had a central axis, and then it had 4 azimuthal domes positioned in a circle on a disc, and then above it on the axle was little planets, like little spheres, little copper spheres and stones and stuff that would be shiny, and those would rotate around, and then you would see them displayed in the azimuthal grids, like through the mirrors, and then the celestial disk that's rotating on top over the axis would go up and down, and that would change in elevation to how they would see them on the ground. And so the way that they conceptualized it back in the day and justified it as flat earth geocentrist for navigation was that each continent had their own hemispherical dome that the heavens were perceived under.
I couldn't understand what that person said, but there's one more question. This is from Morningstar, and I think at the start, Chief Squatting Dog. Why the choice of the word occlusion rather than the word occultation, where the opinion in the chat was that occultation would be the more appropriate word, a term used in astronomy? Why the choice of the word occlusion rather than occultation?
Oh, I don't care, and I just work here.
Yeah, I think the terms are equivalent in this specific example. All right, those are the 3 questions. John had said he had a couple questions that he wanted to ask. He said he wanted a couple minutes to talk to you guys, so I'll hand it over then. That's all I found.
Go ahead, John.
Thanks. Yeah, I just upload once again the screenshot that I posted a couple times, just so it's right there. This is ostensibly a spreadsheet. I give you the link to it, but there's no calculations here. It's just a compilation of results that I think there will be no disagreement on. And I wanted to just limit the number of words. I think one of the problems is when we start talking about all the different peaks and all the calculations, it gets complicated. So I'm going to limit my attention to the original observation of 39 Aquarii being occluded by Pike's Peak on 31 January. I think that's what Roohif was talking about as well. If you look at the thing that I just posted there, I think we all agree that the geometric elevation. So first is flat Earth calculated values. The geometric elevation angle of Pike's Peak from Heffron's house is, I get 2 degrees 31.4 arc minutes. You might disagree with a few tenths of that arc minute, but I think, do we agree with that number?
Yep.
Yeah, and then if you do the same thing, putting in globe drop, you get the geometric elevation angle as calculated on the globe to be 2 degrees 17.7 arc minutes. I think we agree with that. There's a tiny little atmospheric refraction effect between the peak and Heffron's house. I calculate that to be about 1.7 arc minutes. Your mileage may vary, but I end up, and I think everybody basically agrees that the visual elevation that we calculate with standard atmospheric refraction from Heffron's house is 2 degrees. I get 19.4. Once again, you might disagree a few tenths of an arc minute. Fair enough with all that.
I would like to introduce a objection entirely, though, to the refraction correction, because again, the occlusion happens on the other side of the mountain, so the refraction between you and the peak are irrelevant.
Fair enough. But
when you no longer see the star, that's all that matters. But yes, I also include refraction as mine for a comparison too. But continue.
Yeah. Okay. Fair enough. I don't. As far as that goes, I think you can forget. Don't even have to include it. It doesn't change the bottom line.
Well, it does in other measurements, though, because it's a ratio of the distance for how much it impacts it. So it doesn't seem like much in this measurement, but it actually affects it, to varying degrees depending on the ratio of the distance and elevation. So anyway, continue.
Okay, I just want to stick with this one observation. And the globe, the angular displacement, right? This is a number that I know everybody's familiar with. When you go 50.6 kilometers around a 40,000 kilometer circumference globe, that amounts to going up almost half a degree, 27.3 arc minutes. And all objects in the sky that you move toward rise by 27.3 arc minutes. I think you understand that too, Alan. Fair enough?
Mm-hmm.
On the globe. Okay, and then turning to values from stellarium, for which you have to input pressures and temperatures at the observation point, at least for visual things. Stellarium says that at the time that Mike Heffron observed the occlusion, the geometric elevation angle of the star from his house, from where he did the observation, was 2 degrees 5.6 arc minutes. I think that number isn't referenced very often because it doesn't figure in anybody's calculations. But I put it here because it is going to be kind of important. Sorry?
Yeah, I put it in. I put it in for a comparison to the 360 times the distance relationship to track true prediction. Predictions, and then also if we did true position to true position for observer, you guys would never be it would never be close. So it wouldn't really be fair to do that to you guys. To do the 206.
But I think you're saying pretty much what I'm going to do here in a couple of lines as well. Stellarium also says that the visual elevation of the star at the time that Mike saw it from his house being occluded by the peak was 2 degrees 18.8 arc minutes is what I get. Once again, that may be off by a few tenths of an arc minute, but that's basically what I see. I think you agree with that too. And then if you ask
so I got 222, but using I got 222, but Roohif said my refraction thing was off because I didn't have the barometric pressure thing, right? Yeah. So I don't disagree with 218
at first. So I think you made the same mistake that I did originally, not putting in the pressure and everything. Anyway, then if you go to Pike's Peak, as you well know, the Pike's Peak Stellarium says the geometric elevation angle of the star is 2 degrees 32.9 arc minutes at that time. And the visual elevation angle of the star, where it's actually seen, is 2 degrees 42.2 arc minutes, according to Stellarium. So just those numbers. And then I just pointed out, I think the thing that you mentioned there, that 232.9 is the 256 from Heffron's house, plus the globe, plus an amount that happens to be, maybe by coincidence, equal to the globe curvature between Heffron's house and Pike's
Which one are you talking about? Which one was the difference?
The fact that the
refraction correction plus the
no refraction correction. The geometric angle of the star from Pike's Peak is exactly 27.3 arc minutes higher than it is from Heffron's house, which coincidentally enough, I don't think it's a coincidence, but it is equal to the globe curvature between Heffron's house and the peak. That is a fact, whether you think it's a coincidence or not.
No, I don't doubt it. I've seen some interesting coincidences with that 360 relationship too, because there's one I think for the true position from observer location. If you do 360 times the distance for this one, I think it's like a couple arc minutes off in distance in position for the true position of it. But for other mountains, it's like a degree off, so it kind of varies with that. So it'll be interesting to track that per mountain peak.
So that's the data, and I think, as I say, we basically agree on the data. So the first question is, why doesn't it matter that the visual elevation of the star at the time that it was visually at the same place as the peak, as in other words, the time when it was occluded by the peak, that's when it is visually at that same place. Why doesn't it matter that that visual elevation agrees very well with the globe calculated visual elevation of the peak, and not at all with the flat Earth calculated value for that elevation?
That's a great question. And the reason for that is because we're referencing the true position alignment, because the star has a light source, so-called, right? And that's calculated by using its position of where it once was on the first point of Aries with respect to 15 degrees per hour. So when we're comparing what the intersection angle what the physical intersection angle would have to be between the so-called light source and the apparent position. That's why we make the comparison to the position that we don't even see, because we have to, we're going for what the light source would be, right? So that's why there's a difference there. And when we derive our distance based off of that, there should not be any geometric relationship with the occlusion timing, because there shouldn't be a physical peak there at that elevation to cause that angle of occlusion if the Earth is flat versus if it's globe. So that's why we take that's why there's two things are, we derive them off of two separate things. And the globe, of course, is built off of the apparent position. So when we do apparent position at occlusion timing, we get, elevations that are sometimes close, depending on if the refraction was enough to make the apparent position equal to the true position at the peak.
Okay, so I know I do understand why your value is different than this, because you have a completely different method. That's fine, but that wasn't really my question. My question is, why does it not matter to you that the visual elevation of the star at the time that it was observed from the place that it was observed is the same as the globe calculated visual elevation of the peak that is occluding it at that time? Why doesn't that matter?
So that's part of our premise. Yeah, that's part of our premise, that the optical, that the drop, right, that the way it looks is due to optics. It's not due to physical Earth curvature. With the method that we do, that you referenced as being a completely different method or whatever, it's not. It's an external test of the internal consistent method that's based on the optic angle that you would produce. So
once again, I think you're explaining to me why your method gives a different value, but it doesn't actually address the question of why it doesn't concern you that Stellarium reports that when Mike Heffron saw that star at the same place as the peak, it was at the angle that the globe Earth calculates for that peak, and not at all at the angle that the flat Earth calculates. That shouldn't matter.
And John, so check this out, my man. So the refracted process and occlusion process, right? The refracted position can't be what does the occlusion. So think about this. At the same time, simultaneously as your globe angle is being refracted or being occluded by a physical process that is not due to the apparent mountain or the apparent position of the star, because those two things could never occlude one another. When we reference the actual thing that would be the thing that does the occluding, we get the actual distance. Right, so your optical
once again,
angle
I
is
understand
irrelevant.
your
method. So if you say I understand your method again, and then ask why it's not a factor,
let me back into
then that's not a real question. And how are you going to start trying to talk over me in the middle of me explaining to you why we don't care? Like, just actually listen instead of waiting to repeat the same question over and again. We don't care because we're referencing when there has to be a physical occlusion, what elevation would have to be to do that physical occluding. The optical angle matters not to us.
Okay, I know that it doesn't, so we can move on. This is the last question. And that's just this, that if
He
the
doesn't
Earth
understand
is
why.
flat, how can the geometric direction to the star, the actual geometric direction to the star from Heffron's house, where he was actually observing it, is 27.3 arc minutes less than the geometric direction to the star from the top of Pikes Peak. If you draw yourself a little picture like this, I'll put this last screenshot up. I ask you to look at those two. One is the direction to the star. That's the geometric direction to the star. Oh, sorry. That's the geometric direction to the star from Heffron's house. That's the 2.093 degree thing. That's the actual literal direction to the star from Heffron's house. And then that other one there, the 2.548, that's the geometric direction to the star from the top of Pikes Peak. How can those two things point in completely different directions? They can't point to the same thing. They're pointing in different directions. How does that work?
I have no idea.
Am I
what
still
you're
here?
talking about.
No.
You sure?
I'm looking at your graph. What are you talking about, bro? Here's the thing, John. Here's the thing. Here's the thing, bro. No. Let me just explain this real quick. Suppose I have no idea where I'm at, and all I have is an angle that the star wasn't visible at, and an elevation. I can derive my distance based off of that if I use the angle that closely corresponds to the flat, or if I use the angle that the flat Earth predicts would be the angle that closely derives my distance every time. So that's all I care about. I have no idea what your objection is, and honestly,
Well, dude, what he's not differentiating is we're trying to do physical versus optical, and he's trying to confirm it by measuring optics and saying, look, it appears to do the thing we're saying it does. And we're saying no, in physical actual reality, when we subtract the geometric Earth curve from these occlusion timings using the physical timing, the actual timing from the mountain, then it's failing, right? That's what we're saying. So they're saying, oh, we realize that, so we'll never talk about that, and we'll talk about everything else.
Oh, yeah, the classic switch and bait. So listen, that wraps up this week's episode of Celestial Theodolite.
You didn't understand my drawing. Do I get a chance to at least? No,
No,
I don't even get that chance. Okay, that's telling. That's telling.
Yeah, no, we get it. It's another optical comparison. So like when Roohif came through and was like, yo, mine does the same thing. And then he just referenced my optics graph and